Hi everybody, welcome to lesson 2 of our unit on trigonometric identities. Last lesson we started to learn the basic identities, and those are ones that I really hope that you've taken to heart in the idea of internalizing them, because today we're going to apply them again and again and again with some more complex identities. Now, I've mentioned this in class, and I've mentioned this over the year, that there's a whole bunch of different ways that we can do problem solving, and there's no two people that may have the same way of looking at particular problems, especially these math puzzles. So at the top here we have some definite ideas that you need to consider when you're doing trig identities. Specifically, the idea that we may have to substitute for one of the identities. You don't know exactly how we might come about our solution, so sometimes it may be a substitution, sometimes it may be clearing complex fractions, or factoring, or finding that common denominator, or even rationalizing the numerator by multiplying by a conjugate. All of these ideas that you've used over the years of your math now are going to come into play right now. So if we start off with a basic idea here, let's take a look at question 1, where it's tan of x cosecant of x is equal to secant of x. Now, the idea for proving the following is we have to make one side look like the other, or in very rare occurrence, which you'll actually see today, the idea that you have to play around with both sides a little bit in order to make them look identical. But in general, what I would do, and I'll do this for both cases, is you draw a line right down the middle. And in general, as I mentioned previously, the right side is most certainly hands-off. Again, you may have to manipulate a little bit because of some canceling that happens in the original proof that you can't account for when you're going the opposite way. But in this case, this should be rather simple. Rule of thumb always is, if you can, move everything to sine and cosine. So in this case, we can introduce the idea that tangent is sine over cosine, and cosecant is 1 over sine. Well, why would we do that? Well, if you take a look now, algebra tells us we can cancel those sines, and we're left with 1 over the cosine of x. Well, I hope by then you're excited, because we know that cosine of x is equal to secant of x, which now means that the left-hand side is equal to the right-hand side, and we have completed our identity. So take a look. We did 1, 2, 3 steps, and we're done. Is there a longer way to doing it? Probably. There are some people that may take 4 or 5 sets, but generally speaking, this is the most direct way to get towards the solution, and I would highly recommend that we do it as such. Let's take a look at number 2. I'm not going to do it myself. I'm going to let you do it, but again, think about it in the same way. Substitute in for cotangent and cosecant, and see if you can't algebraically manipulate to cosine. Okay, so hopefully we've tried it, because now we should end up with, well, cotangent is cosine over sine of x, and that's divided by cosecant, which is 1 over sine of x. You'll notice how I leave the fractions as is, which means you have to remember that this denominator will drop down, this denominator will pop up, and you're going to end up with something that looks like, oh look, they cancel, and you end up with cosine of x left is equal to right, QED. Sometimes problems, if they look simple, it's because they are simple. Okay, let's look at a question that's a little more challenging now with number 3. Again, the first idea I would suggest is, if you see cosecant, let's go ahead and plug in 1 over sine of x, and that's times cosine of x plus sine of x. Now, remember that idea of factoring? This is definitely where we have to go in this case. And why? What do we need to factor? Well, if we take a look, we have a cosine squared x, which is immediately raising red flags to me that, hey, I could get cosine squared x plus sine squared x, which I hope you remember is equal to 1. And the way to do that is to factor out a 1 over sine x. And when you do so, you end up with cosine squared of x plus sine squared of x. Remember, factoring means you're dividing both terms by whatever you factored out. So dividing sine by 1 over sine should equal sine squared x. In this case, we know that we can just write this as 1 over sine of x. Why? Because that there is equal to 1. Remember your identity. And from there, again, happy days, because we know that 1 over sine x is cosecant of x. Left is equal to right, QED. Why don't you give number 4 a try? Okay, so very much the same thing. Cotangent is just cos x over sine x. And tangent x is sine x over cos x. Well, that's cool, but what do we do with that? Well, I say let's find the common denominator. And the common denominator in this case is sine x cos x. And what are we left with? Well, wouldn't you know it? Cos squared x plus sine squared x. This is a squared. And in this case, this is equal to 1. And you end up with, I'll rewrite it because I have a feeling some people didn't write it like this. Sine of x times 1 over cos of x. And hopefully you remember your identities again. Well, that's just equal to cosecant of x times, secant of x. Yay! Left equals right, QED. So again, very much the same thing. I looked for something that I could eventually simplify to a simpler identity like 1 or tangent squared of x or cotangent squared of x, anything like that. Okay? Let's move along. So number 5 now, again, is yet another new idea behind this. This is a simple expanding out and solving. So we all remember our beautiful FOIL. And if we FOIL this out, we should get secant squared of x plus secant of x minus secant of x, subtract 1. So I skipped the middle terms because they cancel out. If you can't do that, please do that. Now, this particular thing should, again, raise flags. And remember, we're looking for something that has cotangent, which means cotangent is directly related to either cos and sine or tangent itself. And we know that secant squared of x from our last identities is equal to 1 plus tangent squared of x, subtract 1. Or sorry, not the subtract 1, the plus 1, and then we have our minus 1 after the fact. Yay! Our subtract 1's cancel, and now we have tangent squared of x. Well, we know that tangent, or the inverse of tangent is cotangent, which means the inverse of tangent should be cotangent, which means 1 over cotangent squared of x should work just fine. Again, think of it as we're just taking the inverse of tangent squared of x, and in the process, the algebra leads us to here. And then we go, yay, QED. So, I'm going to leave number 6 for you because it's very similar in its ideas. But number 7, this one's a bit trickier. You'll notice that I keep putting the line down the middle. Remember, I've already done this once, this lesson, but hands off. Now, new idea here. We got this ugliness. But this is the idea where you multiply by the conjugate. So check this out. If I take 1 plus cos x over 1 plus secant of x, and I multiply the top and bottom by 1 minus secant of x, well, why would I do something like that? Because the denominator now, when you multiply those together, you remember in the previous example how the middle term canceled out and all you were left with was the 1 subtract secant squared of x. Again, you could FOIL it out to show it, but remember these are two binomials being multiplied together. And then what happens to the top? Well, we end up with 1 subtract secant of x plus cosine of x, subtract secant of x, cos x, right? So once we end up here, now we can simplify into cosine of x subtract secant of x divided by 1 subtract secant squared of x. Now, this particular expression here should raise red flags because you know that that should be equal to negative tan squared of x. And this thing here, we're going to pull out a negative sign, which should make sense in a second. Secant of x subtract cosine of x over negative tan squared of x. Why did I pull out the negative? So that I cancel those out. Now let's plug in for our tangent and secant in terms of cosine and sine. And we end up with 1 over cos of x subtract cos of x divided by sine squared of x over cos squared of x. This pops up and multiplies by that entire term there, which gives us cos of x subtract cos cubed of x. Cos cubed of x, yes, cos cubed of x. Why did we do that? Well, again, you'll see very shortly, because we're almost done. I've run out of room, so we're going to go over here. Let's factor out a cosine of x from the top. And we get 1 subtract cos squared of x over sine squared of x. That there, again, red flag should fly, and you should know that that's actually equal to sine squared of x. Basic identity over sine squared of x. Cancel out, and all you're left with is cos of x. Left is equal to right. QED. Beautiful. So again, it all stemmed from the idea right here. That's wickedly important. That's multiplying by your conjugate. Okay? So we're going to do maybe one more, and then I'm going to show you a little trick about the last question, and then I will set you free. So let's take a look at a question like number 9. We have 2 different denominators. Should instantly tell you, let's simplify and find the common denominator, which in this case is 1 subtract cos squared of x, which means what did we end up doing? Well, we ended up going 1 minus cos of x on that one, plus 1 plus cos of x on this one. And what do we get now? Well, we end up with canceling out 2 over, and this again should raise flags for you, because that's just equal to sine squared of x. Well, if we take a look at it, 2 times 1 over sine squared of x, that's just equal to 2 secant squared of x, which means left is equal to right. QED. So I'm sorry if I'm going quick through these, but the beauty is that at the very beginning, if you see the solution before you start, it's a relatively straightforward idea. And finally, the last one I'll go through is number 11. If we take a look in this case, start off simply by plugging in your sines and cosines. Like so. Okay, well that's cool. What do we do with that? I'm going to pretend that this term here is one term, cos over sine, and I'm going to divide every term by that up in the numerator. So I end up with sine squared of x over cos of x plus cos of x. See how that was there too, and so it canceled out, right? Awesome. Well, this looks like a problem that we've already dealt with before, where I factor out a 1 over cos of x, and what am I left with? Well, I'm left with sine squared of x plus, well, cosine divided by 1 over cosine is cos squared of x. Sweet. We know that's equal to 1. So all we're left with is 1 over cosine of x, which is just secant of x. Left is equal to right. QED. Okay?